Hi everyone, this is Aaron Thompson. I'm an assistant professor of natural resource planning and a land use specialist at UW-Stevens Point. This presentation is an abbreviated version of a training that my colleague Dan McFarlane, our GIS research specialist here in the center, he and I put together for a Land Trust Alliance peer mentoring network. The emphasis of this presentation is really to focus on how GIS can help inform conservation planning decisions. And you'll find that before we get done, we'll talk about how these processes, all of this GIS analysis, needs to be embedded within a larger planning structure to help support land trust work or other conservation organizations that are trying to do this work with stakeholders in the landscape. Here's a quick introduction to the Center for Land Use Education. We're a group of extension professionals that are based off the UW-Stevens Point campus that work with communities to directly support their efforts to sustainably manage their land use, make sound decisions about future land use and natural resource protection. And in addition to that, we're developing a lot of program and educational outreach support for conservation planning efforts, land use planning, and natural resource policy in Wisconsin. As part of this, one of the areas that we've begun to develop kind of a specialty in is trying to help communities use GIS as a tool to support this decision-making process. How can we make better land use decisions by understanding the current conditions today and how our policies, and hopefully be able to model how our policies will affect land use in the future? One of the ways that the center supports conservation planning here in Wisconsin is that our faculty actually split their time between teaching in an undergraduate and graduate program focused on natural resource planning and working directly with communities through UW Extension. One of the real benefits of this is that we often have a number of interns that can go out with the methods that we teach them here on campus, and they can help support strategic conservation planning within land trusts or other conservation organizations. The center also provides a lot of direct training opportunities, and this can be for community citizens who are interested in becoming involved in their plan commission to understand the issues, the process, and really how to become involved in community planning efforts. But we also support a variety of other programs, everything from UW Extension Lakes Leadership Program to efforts to directly train conservation planning professionals on how to use more advanced planning techniques. One of the other areas where we're doing a lot of research and development is in applied natural resource social science. We know that in order for planning efforts to be successful, they have to include local stakeholders. And so some of this work comes in the form of doing community surveys, landowner analysis, but going beyond that, how can we link this information into a spatial framework so that we can evaluate both social and ecological data? One of the other ways that CLUE helps local planners deal with larger natural resource planning issues is that we produce an annual series called Megatrends, and within this series we address large issues that are affecting land use here in Wisconsin. And as you see here on the left, here's an example where we're starting to layer some critical information in about water here in Wisconsin in order to help visualize some of the challenges that communities face. On the right hand side, we pick that up with some of the work that I've done trying to determine what is the rate of farmland loss at the county level here in Wisconsin. This information can be used to plug into farmland preservation plans, help inform where these efforts need to be taking place, where the threat is the strongest, and areas where communities may have to take a different approach. And lastly, we never pass up on a chance to get our undergraduates involved in this kind of work. And so the Center for Land Use Education with our Natural Resource Planning program are very active and involved with a number of different community partners across the state of Wisconsin, often helping to support strategic conservation planning, watershed planning efforts, community sustainability efforts, and a variety of other projects. This way we can get our students out into the field to work directly with stakeholders that are trying to develop strategic conservation plans.
Hi, my name is Dan McFarlane. I am a GIS research specialist with the Center for Land Use Education at the University of Wisconsin-Stevens Point. Today I want to talk a little bit about some of the projects I've been involved with that really use GIS technology for conservation and community planning. But before I start that, I just want to mention that GIS analysis is really about getting answers to questions so you can make better decisions. In some cases, though, the map alone may be the analysis. You make a map and it may have enough information on it to help you get the answers that you need. However, trying to draw conclusions from some of these maps isn't always easy. So in this case, you may use GIS tools and methods to create new data and analyze it to help you draw conclusions. These additional GIS tools and techniques may rely on spatial statistics to help you really cut through the map and get right at the patterns and relationships that may exist in the data. For example, in our parcelization project a few years ago, we utilized GIS and spatial statistics to help us identify what factors or drivers, landscape drivers, were really influencing rural parcelization in Wisconsin. We were really interested in what were these landscape variables that were influencing parcelization. When you look at a plat book or a tax parcel map, it doesn't seem to be a random pattern of parcels. There seems to be some sort of pattern involved. So we really capitalized on GIS's ability to measure and identify those patterns using statistics. Very seldom in Wisconsin or elsewhere do parcels get bigger over time. It's more common to have parcels being carved up into smaller and smaller pieces, which can ultimately have negative consequences for conservation planning. So I'm going to step through a sequence of slides here that really demonstrates a time series of parcelization in a couple of communities in south central Wisconsin. What you're seeing right now is a parcel layer from roughly 1950 that we recreated using GIS. And as you can see, much of the town is 40-acre parcels with some smaller parcelization along the Wisconsin River. As I step through here, you'll see in 1960 some more parcelization occurring. And current, you're starting to see pockets of parcelization occurring away from the water, but also seem to be clustered in some areas throughout the town. So we really wanted to measure that pattern and see what sort of landscape variables were influencing some of these pockets of parcelization. So going just beyond the map, we use spatial statistics to identify these clusters or hot spots of where parcel subdivision is occurring throughout the town, such as these highlighted areas here. Our ultimate result of this was a probability map here displayed from basically a red color scheme to a blue, where we symbolized red parcels that had a high probability of splitting in the future based on past trends and the landscape variables that we included in our model, and the blue areas where we would have less probability or a lower probability of parcel splitting. So this was very helpful for not only the town and the county, but also groups that were looking to protect sensitive properties. So groups that were interested in highly sensitive properties that had a high probability of parcelization in the future, they could allocate much of their priorities to those properties. If you're interested in this project, we also have a peer-reviewed article here that I've got up, as well as some of the landscape variables and their influence on our final model. If you're interested, I recommend reading that article or contacting us for more information. The new generation of conservation planning with GIS technology is really a rapidly emerging field. CLUE has utilized some of these emerging technologies, such as Community Viz, which is a GIS add-in to Esri products, with a remarkably wide variety of planning applications. For example, I've worked with lake and watershed groups to analyze zoning regulations and comprehensive plans to help them understand how their local policies could play out on the landscape. We give these groups the technical capacity to gather, analyze, and display this GIS information, as well as to involve them in envisioning their community's future and the decisions they make at the planning process and what potential impacts these have on their valued natural resources, such as lakes, streams, and forests. In this case, we use GIS to develop residential build-out scenarios, or how many homes could possibly be built and where, given certain constraints, such as landscape constraints, wetlands, steep slopes, setbacks, minimum lot sizes. And we use this to not only display what it could look like, but also to measure change. Change in landscape fragmentation, change in loss of farmland, as well as change in potential impervious surface. So we use the results of these models to also model other things like potential change in water quality, phosphorus and nitrate levels in the water, as well as forest fragmentation, loss of habitat, things of that nature. So it's a really good envisioning process that the stakeholders value and can measure their plans and policies on the landscape. Lastly, I just want to talk briefly about some of the projects I've been involved with regarding field techniques, mobile data collection, as well as web mapping. This slide you've seen earlier during Aaron's presentation, so it should look a bit familiar. I've been involved with several projects that utilize both GIS and GPS technology to collect data in the field, primarily about shoreline health. Anything from man-made structures to vegetative buffers and other issues that could affect shoreline health. Originally, when I was involved with this project, all the data collection was done using really old Garmin handheld GPS units, and that were really only for capturing waypoints, as well as data collection sheets, paper sheets. It was a very tedious, slow process in terms of not only collecting the data, but also coming back in from the field and recording that information into a GIS. It was a very the data entry process was actually probably the most time-consuming rather than the field work. I got involved and really wanted to take advantage of where the technology was going in terms of mobile data collection and web technology. So today we're using our campus's web and server technology, as well as Esri's ArcGIS Online organizational account, which is really basically a cloud-based GIS solution, to develop these mobile applications for field data collection on both Android and iOS devices. The nice thing about that is our students that primarily collect this data are very techy. They've been using these mobile handheld devices for quite a while. To actually train them to use the old Garmin GIS units was probably more difficult than actually teaching them how to use their own phones or tablets. So now these field crews, they go out, we set up a project, they download it to their device, and they can collect data in real time. When they get back to campus, they're able to sync up their device and the data back to our master GIS database, which is stored on our server, and we're done. There's a little bit of quality control that's performed in the office, but for the most part, all the data collection and data entry is done when they get back to the office. The crews are finding that the mobile data collection applications, particularly Esri's Collector app, is really easy to learn. For me, it's really easy to configure and has required very little training after we initially adopted it. So through Esri's cloud-based application, we're now able to collect really valuable information and quickly return and turn it around for use by others. And then what we do is we use Esri's web-based mapping applications, ArcGIS Online, to then develop these web mapping applications for lake groups or other groups so they can see the data, interact with the data, and we become a little bit more transparent that way, other than just static hard copy maps.
And before I dive into my part of the presentation, I just wanted to stop and give you a quick introduction to who I am. As an assistant professor and an extension specialist, I get this opportunity to work both directly with students who are learning how to do this, but also with communities and conservation partners that are actively working in the landscape. My background comes from both from landscape architecture and planning, but also I'm trained as a social scientist, and this dominates a lot of the work that I do for communities, trying to help them understand who are the willing partners in the landscape, how do we bring together collaborative initiatives in order to build community discussions to help solve natural resource problems. In addition to this, I also serve as the president for the North Central Conservancy Trust, our local land trust here in central Wisconsin. As I mentioned, being both a planner and a social scientist, I kind of end up exploring these problems that cross over into this world of social ecological analysis. How can we bring an understanding of the landscape and combine it with an understanding of the people who live there in order to solve natural resource problems? The Wordle on the right just gives you an understanding of kind of the diversity of these issues, but a lot of my work is really focused in on trying to understand the attitudes and behaviors of agricultural producers and how we can engage them in a conservation dialogue. And at the core of my work is an understanding that planning is both an active decision-making process by which we make firm commitments of resources to solve problems, but planning is also an active process. It's not something it's quick or easy. It's about building a community dialogue that can last over time. In the end, we're trying to build a coalition of partners that can respond to changing conditions in the landscape, and I think that that's a primary emphasis of what I do when I work with communities. But this presentation is really about the GIS side of what I do. And so I just wanted to start with kind of how I got brought into this. GIS is this amazing, complex software that can answer so many questions. But until you've actually defined what it is you need from it, it's very difficult to kind of jump in and get started and going on these. And so the question that dragged me into this is that as a master's student, I returned to Indiana, which is home for me, and I had the opportunity to study farmland loss, looking at, where are we losing farmland to urban development? And one of the simple questions I couldn't answer, even after, spending several months kind of looking for this, is that where was the accurate number? How much farmland was being lost in the United States? And more specifically to my question, what was happening in my own backyard? And then I learned the complexity of GIS. It seemed like a very simple process. How do we take historic land cover data, in this example it was 1992, and overlay it with land cover data from 10 years later in 2002? Well, that seems like such a simple process, but the reality of it is that it takes time to know the limitations of the data, to understand the assumptions you have to make and spell them out in a way, to correct for errors, and work your way through this process. But while doing this, I learned the power of GIS and spatial analysis, and I also learned that this is a series of methods, and it takes time and it takes training in order to understand how to use them properly. And just to share the result really quickly, what we really learned is that farmland was being converted to developed uses very quickly between 1992 and 2002. Now we know because of what happened kind of with the recession that this slowed down shortly after 2002. But what we absolutely saw here was we saw more than 1 million acres lost in these two states over that 10-year period. Just think of the scale of landscape change that's occurring based on this trend from land that was farmland to land that is now developed. I wanted to present just a quick example of what this could look like. What's going to follow are about 10 slides that progress very rapidly through an analysis that was done by one of my undergraduate research assistants. This was to help support the work of a land trust, the land trust that I'm involved with actually, to figure out where to prioritize properties, or how to prioritize properties for conservation. And so I'm just going to show you. It's a very simple GIS overlay analysis, and we'll walk through it step by step. The analysis begins with looking at existing land cover data and at the pattern of parcel ownership. We then look at existing protected lands, both state lands, locally protected lands, and existing easements. We add in some information about water resources, those parcels that are near lakes and near streams. We then were able to take a look at the forest, and this particular analysis was performed with a spatial fragmentation toolbox that was developed by the University of Connecticut Center for Land Use Education and Research. And this analysis helps us understand not just where forests are, but also where are the large, intact, core forested areas. We then summarize those results. and use the overlay of all of these different layers to arrive at priority parcels. Again, in this particular analysis, we are able to identify 44 different parcels that met the different criteria that the Land Trust has developed for selecting lands for conservation. There are many different ways to conduct this analysis, and the overlay progression that I presented here is fairly straightforward. Weighting schemes, adjusting for other priorities, incorporating community comprehensive planning into this process are all other facets that could be included. But moving beyond just simple priority parcel analysis, conservation planning also requires that we balance the multiple demands that we as citizens, as landowners, as communities place upon these properties. And so there is a much bigger question at play here, understanding whose priorities matter. Well, as I note here on this slide, this question speaks directly to why we have to participate in a longer, more comprehensive planning process, because there are no simple answers to this big question. But if we understand that why we would engage in such an activity is about improving conditions on the ground or addressing problems that we know exist, that means that we're trying to make some kind of change from what we see either now in terms of the trends or now in terms of what we see on the landscape. And in order to achieve that, we have to understand that this is going to be influenced by a wider range of stakeholders. Those who are responsible for implementing our plans, those who are affected by our actions, and others with a stake in the community. This is a really important part of the process, and it's one that we have to do a better job of engaging a broader coalition in determining conservation priorities for the landscapes that we're working in. Because at the end of the day, it all boils down to this simple quote here at the bottom. Those stakeholders who have a hand in shaping the plans, in making the decisions, in being part of the process of deciding what land gets protected, are more likely to support our efforts than those who've been left out or excluded from this process. Which brings me to an example. Over the last 5 years, I've been doing a lot of work on grassland management here in central Wisconsin. And there's one species in particular that gets a lot of attention here I'll introduce in just a second. But just to give you an idea, this is a long-term management process. Realistically, there's more than 70 years of active conservation to try and save the grassland habitat here in central Wisconsin. And so I'm going to talk to you a little bit about how both GIS, so spatial analysis techniques, but also broader planning initiatives are playing a role in how we move forward in this landscape. And enter the prairie chicken. The greater prairie chicken here in Wisconsin has served as a very charismatic umbrella species for grassland management in central Wisconsin. Once widely distributed throughout the state of Wisconsin, the only remaining population left is within the central Wisconsin grassland conservation area. However, as it shows here on the slides, things haven't been going well for the prairie chicken. And if you look back over the last 70 years, their numbers have pretty consistently gone down. This is a huge challenge for us because a lot of what we're seeing here is a change in the landscape, a change in the pattern. We can use GIS to help understand that change and help in order to inform future management actions. Working with one of my graduate students, Jacob Hernandez, he was able to take a look at land cover change, and specifically grassland change, over the last 20 years, so from 1992 to 2010. Again, this seems like a simple process of taking land cover from one period of time and overlaying it with land cover from a previous period of time. But there's a lot of working with the data, determining which data works best for your needs, ensuring that you're creating the best available estimate to support this work that comes into play here. And so he worked through this process, and I'll show you the results on the next slide. And what we found was that we're seeing a decline in grassland across this landscape. Across all of central Wisconsin, all of the counties that are included here on this map, there's almost a 20% loss in grassland. When we go inside of the dark green boundary that he's drawn here that represents the kind of S-shaped central Wisconsin grassland area, there's a 15% loss of grassland habitat, and the primary driver behind that has been conversion to row crop agriculture. We see in the larger landscape and in the management area as well that conversion back to forest, and so simple succession, is also playing a role in this change as well. But knowing where the grassland is being gained or lost is only part of this equation. We also know that conservation planning requires social science, because what we're often missing is an understanding of the attitudes, priorities, and behaviors of those who actually live and own the properties that are part of this matrix of lands that we're trying to manage. We know that landowner attitudes also have an inherent spatial component. Farmers who own not just the farmstead, but own hundreds of acres spread out over a town or multiple towns within a county, in some cases even going well beyond that. Certainly there's a spatial problem to be solved in there. They're making the management decisions. They are the ones that their opinions will drive whether or not they will or won't support our conservation efforts, and we need more information about them. And so what this means is that strategic conservation planning, if we're going to target our limited resources to solve the problems that we're facing, we need an understanding both of the ecological conditions of the landscape we work in, but also of the social conditions, so the social component or the social landscape, and for that we need to be doing the type of human dimension analysis that can help inform this work. Because ideally, we'd like to be able to take an understanding of where the ecological lands are that we're targeting. So in this map you can see the greens, both the dark and the light green, are forested areas. And if we're going to protect riparian forest in this particular county example, we also want to understand where are those landowners who are our willing partners, those that share our conservation mission and or are willing to support us in our efforts over the longer term. And if we can use methods that integrate social survey data with a GIS analysis, understanding where those landowners control property, hopefully we can get to a place like this map, where we can evaluate the land not just based on the ecological conditions, but also based on an understanding of where people own property that will support our efforts. Now, understanding that there are definitely those landowners within this landscape, and I could light this up in a very different direction, of those that don't support our efforts, that don't want to be involved in this, and that's important as well. But in this particular example, you can see how we can zoom in with the biophysical information to the areas that we want to target, and then we can add in the social information to where those willing partners, where do they control property within our study area. And then just for a couple slides, indulge me if you will, I want to talk just a little bit more broadly about where else we need to be going with social science information. It's not just enough to know what someone's priorities are, because we still have to engage them in a process. So how do we bring rural landowners into this decision-making process? A lot of my work right now is looking at what are the models, the approaches that rural landowners are most likely to respond to participate in these efforts. Because these results can really inform how we need to be proceeding. How do we, as conservation organizations, land trusts, or government agencies, how do we bring rural landowners in and respect the contribution that they make to our planning process, to understanding their priorities and figuring out how we can make their priorities our priorities and still achieve the conservation mission we set out to go after? A lot of this comes back to it's about planning. It's about having a community discussion about where we're going. It's about building relationships over time in order to build the capacity it's going to take to not only accomplish but also sustain conservation efforts well into the future. And then hopefully we can use this information. And in this particular case, I'm showing you some of the Prairie Chicken landscape again. We're starting to zero in on who are these landowners, how do they prefer to be involved, and we're trying to map that back. So the areas that are kind of bubbled out, the bevel, that pop out in red kind of within this, we've been looking at these landowners and their preferred ways of engaging in this process. And we're not done yet. There's a lot more information to come. But this is a first glimpse at how these individuals want to engage in this process. Who owns the land within these townships that also have our priority grasslands? These are important questions that we need to begin to answer. And it goes well beyond just how we want them to get involved, but we also need to understand what are the priorities they will and won't support over the long term. What are the messaging strategies we need to bring to bear to get them involved in conservation? So just as a quick glimpse here, these were the final questions I included in this survey that went out to landowners. This is what the results came back. We looked at two different priorities. How important is it to you to continue managing for the greater prairie chicken versus how important is it to continue managing for grassland habitat? And I just want to point this out briefly. The change in those words between a state threatened species as the focus of management and grasslands, we saw a significant change in how many people were willing to support those priorities. And I'd like to end here. I do a lot of work with rural landowners throughout the Midwest. And what we find over and over and over again is this desire or need to be included in whatever the decision-making process, the skepticism of decisions that are being made without their involvement, and the lasting implications of that. We need to do a much better job of recognizing the key role that these rural landowners play, both in terms of our process, but also in terms of achieving long-term conservation strategies. It's not always easy to include the social landscape into our decision-making process, but it is absolutely essential to understand how do we approach landowners, who will they trust for information, what are their priorities, and how do we best go about engaging them in this process. All of this work takes time and energy and an investment, but using a strategic conservation planning process that allows us first to zoom in on the ecological landscape and target the areas where we can do the most good. Hopefully that'll help us then zoom in and understand the social landscape at play behind that and determine where our efforts are most likely to have the biggest impact.